Okay, for this one, we got y equals ax squared plus bx plus c. This is standard form for a quadratic. And if the a is positive, then the parabola will open upward. So a parabola is just like a smiley face or a frowning face. If it's positive, if a is positive, then it's going to be a smiley face. It opens upwards because it would continue upwards in both directions. If that a is negative, then it's going to open downwards like this. So again, it would be that both ends of that parabola are going to go downwards. Now this creates an interesting situation for us because the steepness of the y-intercept will depend on where this either one of these parabolas, where it falls on the y-axis. Because, for example, is let's say that I have a smiley face like this. If my y-axis is somewhere to the left of the vertex, let's put the vertex right there, then we can see that this line is going downwards, right? Downwards, 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 which would make the steepness at the y-intercept a negative. Okay, so if that happens, it's negative. If by chance we have the same parabola, but now the y-axis is on the right side, now you can see that it's on the right side of that vertex, so it's going to go up, up, upwards, and so this would then make it positive. The same idea is true for our frowny face parabola. So if it was down like this one, and if the vertex was at the tip there, then the x-axis, the y-axis rather, is right here. Again, you can see that this is going upwards, upwards, upwards as you get to the y-intercept, and so that would make the y-intercept positive, the slope positive at the y-intercept. And if by chance we have the same or a similar parabola, the frowny face, again, if that's my vertex, then anything to the right there, now I can see it's going down, 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 which would make that a negative right there. So you got to be careful, think about which it is, because whichever one it is crucial there. Remember, it's going to depend on where your vertex is and which side of the line it's on, and then also if it's going down or up, down and then up and then down, up and down. But you notice right here, like when we look at the a value, we're just looking at which direction the arrows are going. For here, we have to determine which direction it's going from left to right. So that's also pretty important right there. This is a left to right basis. Now the last part here, the y-intercept and shifts the graph up or down. Really, you're just looking at the c value because at your y-intercept, your x is always going to be 0, and you just find your corresponding y-intercept. For these particular problems, it is the c value. So if the c value here is positive, then you know that that it's going to be a positive y-intercept. If it's negative, it will make it a negative y-intercept. Okay, and that would be true if you were to look on a graph. For example, something like this one, let's say it's a smiley face. Again, you'd look at the y-intercept, which is where the line goes through the y-axis, and again, the x value is always 0, but right here I can tell whatever the y value is, it's going to be negative, which then we would say the c value is going to be a negative. Now, the last thing I need to mention here, because remember, on these 4 scenarios for the y-intercept, here with these ones, we went to the left and then to the right. If it's a smiley face parabola, if it's a frowny face parabola, then we went to the left and right there. But what if the y-intercept is actually the vertex? Okay, so let's say that I had a smiley face one rather. And again, this is my vertex right there. But let's say that my y-axis is going straight through there. If that's the case, then it's right at the tip of that, meaning it's not really going down and it's not going up. It's just straight flat right there, and in this case, it would be 0. Not at 0, it's not at 0. I'm just showing that the slope there is 0 because it's right at the tip. It's where it changes from going, in this case, downwards to upwards, and it has to change at 0. So if your vertex is the y-intercept, then you have a b value that is 0. So this problem will demonstrate that perfectly for us. Okay, now the first thing here, let's do the value of a is, well, this one's opening up downwards. So since it's going downward, then I know that my A has to be a negative. Okay, well, what about the B? This one is where my B, again, I'm concerned with the y-intercept, which is here. That is at 0, -1. And since that is also the vertex on this problem, the y-intercept equals the vertex, then I know that B would have to be 0. If it were anywhere else, then I would have to consider, okay, where is my y-axis in relationship to this? Like, again, if my y-axis were right here, if it were this line, then I would say that my B would have to be positive because it's going upwards right there. Let's say that the y-axis was this line, then it would be going down right here as well. Last thing I got to do right here is to figure out the value of the C. Is it positive, 0, or negative? If it were 0, then it would have to be right at the origin. But right here, I can see it's below the origin, meaning that, well, you see right here that the y-intercept is showing a negative y value, which means that the C value is also negative.